talking about Cramer's rule and determinants today. Now, determinants we did talk about yesterday, and I introduced Cramer's rule in its most elementary form, and we're going to kind of reach its full potential today. First thing I'm going to do is I want to review over determinants, because if you can't do a determinant, then you're not going to be able to do anything in this section. So we're going to look at this matrix, the 1, 2, 1, negative 2, 0, 3, and 1, 3, 2. I originally intended to do one of your homework problems, but in all of my genius, I totally forgot your paper at school, and I don't have a copy with me. So I'm not going to be doing one of your examples, but I will do this one. And so if you've done it correctly, you should be able to determine if you've got your answers correct or not. So here we go. I've kind of created this graphic for you. This is a lot like what's in your book. And so I kind of showed you as we go down the line. Let me keep moving this down just a bit. As you go down the line, there will be 1, 0, and 2. That's where you see in the first group. And then 2, 3, 1. That's in the next. And 1, negative 2, 3 comes in this group. And you can see the lines. You multiply down the lines and place them in the first, second, or third positions in each group, and then we're going to subtract. Now, one thing to note that, remember, we repeat or we rewrite the first two columns of my matrix out on the outside so that I can actually do this multiplication and make it easier for myself. This is called the lattice method, and you can see exactly why, because of the lattice pattern that you see in the inside the matrix. When I go through here and I multiply, we always go ahead, we multiply, 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 and then we add the values together. And you do that in both groups. Once you've got that completed, you will add or subtract if your values turn out to be negative, like in this case. So we'd end up saying 0 plus 6 minus 6. That negative sign just simply comes down. We have 0, we have 3 times 1, which would be 9. And then 2 times negative 2 times 2, which would end up being negative 8. Combine all these values, and then we do a subtraction at the end. And this is a mistake, so let's fix it. It would be 0 plus 6 minus 6, so that's going to end up being 0 minus 9 minus 8. So it would be negative, or in this case, minus negative 1, or minus positive 1, so that's going to be should be a negative. Let's go ahead and fix that. And so I'll put that up. And so this makes this our result of our determinant. So we have a result of negative 1. That should be pretty straightforward in terms of just the way you do that. If you need, you're going to be using this extensively in the work you're going to do with Cramer's rule today. It will be using 3x3 determinants, so that's a prerequisite for solving these kinds of systems. I'm not going to do a whole lot more with that, so if you have a hard time with that, go back and look over this, or listen to that part, rewind it, and listen to that part again. Remember, real quick, it's just you multiply the red first, multiply down each line, and that's what we have written in these little sections here. Then you say it's a subtraction, always in between the two, it's always a subtraction. Then you're going to multiply down this direction, and you're going to write them down in this case. Simplify the multiplication first, add them up, being careful to watch for your negatives, and then you're going to make a subtraction, and that's your final product there. This is the determinant of a 3x3 matrix. Let's move on to Cramer's rule. Yesterday I introduced Cramer's rule, and I'm going to do that one more time just to kind of give you the basic idea of Cramer's rule. Now this is just a copy of your notes. Now on the website, underneath this video, you should have a link to download this exact copy of the document. You might not be able to print it out right now in class, but you can pull it up while you're working on your classwork, or the worksheet that I've left for you that you got yesterday. You should be able to at least have this up and kind of scroll through it if you don't have the video up and running. And so here's your 2x2 rule for Cramer, or Cramer's rule for a 2x2 matrix. We start off with two variables. That's going to mean I'm going to use a 2x2. If I had three variables, we have it down here of a 3x3. We'll talk about that in a minute. And so first thing I need to do is set up matrix A. It talks about here's the solution x equals this, y equals this. Well, you have this little a at the bottom, determinant of A, and you have all these letters up top. Well, it's going to come by starting off writing out matrix A. It's just the coefficients of x's and y's. So you have 2, 1, 2, 1 here, -3 and 2. Place those in positions just like this. The next thing we have to do is we need to find the determinant of that particular matrix. So let's scroll down and look at that determinant. 2 by 2 is simple. It's just like 2 times 2 minus -3 times 1. You can see that here. 2 times 2 is 4. Minus a -3 would give me +3. So 4 plus 3 is 7. And that's my determinant. Now, that's not the end of it. We're going to take these formulas. So if you get confused, kind of pause it and see how I've written this out. I'm going to put these in place. Remember, this is A, B, C, D. The numbers all across the equal sign, this is going to be an E, and this is going to be an F. One more time, that's A, B, C, D, and this is E and F. You can look right here, and these are the two equations they have for you. And this is where E, F, A, B, C, D all come from. One thing to note here is if you do the determinant to start with, and that determinant is 0, it means you can't do it. And it says if the determinant of A equals 0, then the system has exactly, or doesn't equal 0, then the system has exactly one solution. That's okay. That's good. If the determinant is 0, you stop. You cannot use Cramer's rule if your determinant is 0. That is simply off limits. So if it does turn out that way, you'd stop and say you can't use Cramer's rule, and you'd move on to the next problem. So let's keep going with this thing. Okay, let's find x first. So this is the formula you saw on the table. So I went ahead and I plugged in my E and my F. That was what was across the equal sign. And B and D are here, what you see. So really, what I remember is wherever I have, whatever variable I'm solving for, well, that's where I'm going to put my E and my F. So this is where the x's were in the original matrix. So I put my 11 and my 1 in place. And I'm going to do the determinant and simplify. So that's going to be 11 times 2 minus 1 times 1, or 21 over 7, which ends up being 3. All right. The next one is y. Since I'm solving y, I put my E and my F in the y positions, the coefficients of my y's, and I plugged in the values, 2, -3, 11, 1. Then it's 2 times 1 minus this diagonal, so minus -3 times 11. So that's 2 plus 33, which is 35, divided by 7, which ends up giving me 5. If you need to go back and look at this again, do that. I mean, this is kind of what we looked at yesterday. I'm just using these formulas, and this is how my equations are written out. And you can see the kind of the equation start here. Here's my matrix A. And then just found the determinant. And using those two things, I plugged into the formulas here, and I just worked them out. Not too bad. This is actually something really straightforward. The next step is going to be using what you see in the bottom right here. That's fairly complicated. You may have to watch this video and rewatch this part of it. Just take it a step at a time and don't rush through things. If you can do a 3 by 3 determinant, if you can use that lattice method, then you can do this. So I kind of brought that down for you, enlarged it just a little bit. And we're going to go ahead and do a few things. Let's just kind of define a few things first. The matrix A, like before we only had 4 terms, so only needed 4 letters. It was A, B, C, D. Well, I've got a lot more than this. I've got 9 positions, 9 places now. So we have A, B, C, D, E, F, and G, H, I. All right? And that would, of course, correspond to all of the numbers in front of X, Y, and Z. A, D, G, this column, represents the X's. B, E, H represents the Y's. And C, F, I represent my Z. And you can see that in matrix A when I filled it in right here. You can see I simply went straight down the line and just filled in all the values for this. Right? So if we left off with I, then naturally 32 is going to be J, K, and L. Right, so you're going to see that here. If you look up top, J, K, L is in the first row, then it's in the second row, and then it's in the third row. Whatever variable you're solving for, that's where your J, K, L is going to line up. So let's look at it. The first thing I did was I found the determinant of the original matrix. Remember, that was a lattice method, so I went ahead and did that just to save time. I don't want this video to be 25 or 30 minutes or longer, so I went ahead and just kind of did that ahead of time. It turns out that my determinant is negative 45. If we take that determinant, let's look at finding x and y, and then we'll do z. I'm using Cramer's rule, and it's straightforward. Now, on my screen, it looks extremely condensed and quick. Now, I realize that finding this determinant is doing an entire 3x3 matrix. So effectively, by using Cramer's rule, you're going to have to do a determinant 4 times. Once for the determinant of the original, once for x, once for y, and we'll just pull up z, and once for z. Now, after I've done the determinant, then the problem becomes very simple. You do your determinant, so I worked this out. It turns out that determinant was positive 45, divided by my original determinant of negative 45, which gives me my negative 1. I went to y. In this case, you notice that what changes now, what I had in the x column now is in the y column, and my original negative 651 is now back in the original x. So I do this one. I do the determinant. It turns out that was negative 270 over negative 45, which gives me positive 6. And then now, as we go to the z, you find that the J, K, and L filled in the z column. Finished this determinant, and I found it to be negative 90 over negative 45, and that's going to be equal to 2. Now, your assignment is to work the 2x2 matrix for Cramer's rule. To do the 2x2 when you have a situation like this where you've got just x and y. Your assignment is to complete all of those, since those are fairly straightforward. And you have a number of the big matrices for 3x3s. What your assignment is to complete is to do at least 3, or just 3, of the Cramer's rules with it has 3 variables. You have a lot more that to choose from, but pick 3. If you can complete 3 of them, you can do them all. So you don't have to finish the whole thing, but you will have to complete 3 of them, and I will grade for accuracy on these items. So make sure that you do a good job. You should have plenty of time. The video only lasted about 15 minutes, so if you need to go back, check over these things, or rewatch some of the parts, make sure that you do that, especially about the Cramer's rule when you have the 3x3. Okay, watch it again if it was a little confusing, or pause and kind of follow along. Maybe get one of the problems on your paper and kind of see if you can follow along with me and do the steps as I do them by finding your determinants and plugging them in and finding x, y, and z. Your homework. Yesterday I assigned the determinant, the front page, and I want you to complete that one. If you haven't completed that, make sure you complete the whole page. On the back, where it's talking about Cramer's rule, you are to complete all the 2 variable problems, the one with x's and y's, and you are to choose 3 of the ones with x, y, and z and complete those. We will be taking a quiz tomorrow over these items. Okay, we'll have a little short question answer session when you get to class tomorrow, so if you do have questions, you'll get a chance to ask. Be sure to make sure you know how to do these things. Make sure you have them completed. Okay. After we do the question and answer session, you're going to turn this in. I'm going to give you a short quiz, and then you'll be done. So rewind, rewatch, practice, so that tomorrow when you come in, hopefully you'll have most everything down and just have a last minute question to get answered. If you need to come in before school on Friday, I will be there at 7 o'clock to answer any extra questions that you have. Use the rest of the period to work on your assignment. I'll see you guys tomorrow.